A sada je stigao I red na našeg prvog pozvanog predavača. Ladies and gentlemen, let me introduce you Dr. Eng Lim Goh, one of the leading HPC and AI visionaries, Vice President and CTO of Advanced Computing and AI at Hewlett Packard Enterprise. He will deliver a keynote on data edge to cloud, key disruptions from AI. In his lecture, Dr. Goh will talk about the importance of supercomputers and artificial intelligence, their peculiarities, and their benefits they bring to the implementation of scientific research. Special emphasis will be on the relationship between advanced computing and artificial intelligence and how these two areas develop together, the differences and similarities between them, and how one affects the other. Please.
Thank you.
Thank you.
Thank you very much. Thank you, Diana from the ministry, and thank you, Slaven, and thank you, Ivan. Ivan mentioned about big data in his first slide, and it is very relevant to the talk today because machines can be intelligent mostly because of big data that it is learning from. So let's start with the hottest topic today in terms of disruption, generative AI. It is a type of AI that is called generative AI because it generates things, generates text, generates pictures, generate even music of their own, right? And these kinds of generative AI are typically, not always, but typically built with large language models. That's why you hear these two terms a lot. What are large language models? They try to mimic the brain, not quite, but they try, right? And in terms of connections, like so. A grid of points, and all the point on the top left connected to all its immediate opposite neighbors. So on, so on, so on, right? So a lot of connections, right? Same with the next column and so on. I've only drawn 1,000 connections here. It took me 5 minutes, right? These large language models have billions and billions of connections. I'll be 1,000 years old before I finish, right? It's a lot of connections, yeah. So that's the first thing, right? And each connection has one value. So billions and billions of connections, and every connection has one value. And then during the training process, it consumes billions of words on this side. And then every time it tries to predict something, if it predicts wrong, each value is adjusted a bit. So you need a lot of training, right? A lot of data to feed in order to adjust each of these values. So they take months to do so, right? GPT-3 used about 300 billion tokens or 300 billion words to be fed, and then all the values adjusted for the connection. So some connections become stronger, some connections become weaker. Just as an illustration, salt and pepper becomes very strong connection, but salt and spoon become less of a connection. Salt and laser, probably no connection. I don't know, right? So you can see over time, the connections are strengthened, some connections are weakened, some connections are removed. So that's the training process. After training, you start to use it. When you use it, you can prompt it with a text, and then it generates text at the other end. That's one example. ChatGPT in February, I prompted with this text. Then it generates this for me. So prompt, generate, prompt, generate, prompt, generate. Now, the first point to note, it's a beautiful answer. I just love some of the answers it gives. A beautiful answer. First thing to note about this is that this was not my first try. I personally decided to try 20 times, and I picked the one I like. So always remember, when someone shows you a beautiful answer, sometimes ask how many tries, right? I picked this because the first answer it gave me was about wolves chasing the deer. Not very nice in a nice environment, right? So I picked this one that's a bit more serene. But I could also have prompted by saying, while in the forest, a deer, please complete this sentence for me and answer to me in a serene way. You could also prompt it this way. But I didn't do. I just say, while in the forest, a deer. I do it 20 times. And then each time the answer is slightly different or very different, and then I pick the one I liked. So this is how you work with it. Yeah? Now, why is it giving you a different answer every time? Because there's a creativity button. Yeah, you can adjust the creativity very high, and then it'll give you very different answers every time. Or you adjust the creativity very low, it'll give you the most popular answer. So you have that knob. But in this free version of GPT that I use, no knob to adjust creativity. Right? They use the word temperature, but actually it's really a creativity button. Temperature can be 1, very creative. Temperature can be 0, non-creative, very strict. Yeah? They tend not to use temperature 0, very strict, because it'll give you a very bland answer. And then as the answer gets longer and longer, it becomes repetitive sometimes. Yeah? So this is one example. Right? Remember, you can try many times to get different answers. 2, it does it word by word. Keep that in mind. Meaning, when I give it this prompt, it actually looked for the next word only, not the whole answer, the next word only. Of the 20 times, suddenly came out 9 times, appeared came out 3 times, and so on and so on. They add up to be 20, word by word. So because of the sentence I picked, dash was the one. And then what happens there? It then takes the word dash, combines it with the original prompt, and then sends the whole thing back again through the billions of connections. Every word is combined back and sent it back through the billions of connections and recalculated to get the next generation, the word across. After you get that next word, it takes that word, combine it with the original again, send the whole thing back through the billions of connections to predict that next word, and so on and so on. So the key point here is that it predicts it word by word, and every time, for typical models, they fire up all the connections again. This is the second thing to remember when you're using these large language models. They might improve in the future, might be smarter about not activating all the connections, but for now, that's what they do. There can be also text to pictures. This one, I switched the model from ChatGPT to Midjourney. Very popular. In August of 2022, someone keyed in a description, came out with a picture, sent it to art competition, won first prize. A big furor, right? Won first prize. Now, when the judges realized that the first prize was given to someone doing this by describing text, producing picture, they still decided to award the prize because this was for digital art photography. You start to think, right? But the key point, another key point to remember is this person called an artist or an author? So you start to see these things are starting to make us think that society is changing. Are you presenting yourself as an author, or is you presenting yourself as an artist? Can you call yourself an artist? Right? So you start to see these generative AI capabilities now are starting to also make society rethink even your job roles, for example. Oh, by the way, in February of 2023, the US Copyright Office refused to grant copyright to pictures produced by Midjourney. This is a big test case. The letter is actually published, you can look it up, and they say, we cannot grant copyright to this picture because it was not the result of human output. Right? So again, things are changing, right? Regulations are coming, they are just starting to come up, and countries need to think what they should do with regulations like this. But at least the US Copyright Office have already made a statement. Yeah. No copyright, yeah, to the author. Well, it was the author that created a picture book The copyright was given to her for the picture book, but the individual images in the picture book created by Midjourney was not copyrighted. You can also give it a picture and ask the model to tell you what the model thinks. Okay, here I use the German model, Aleph Alpha, the company. The model is called Luminous. So it's not ChatGPT, it's not Midjourney, but here it is Luminous, right? I was at a show like this the night before. I took a picture from behind, gave it this picture, right? And then I give it an additional prompt to just guide it as to what it wants to tell me. I say, the feeling is that. The answer, the event is going to be success. I say, right? Actually, imagine after a hard day's work of setting up the show, a Slaven would know, right? You go back to your hotel room tired, right? For me, after talking to my wife, I would want to talk to this model. I give it this picture, and it reassured me, right? So imagine, right? You're starting to form a relationship with this thing. Next day, when the audience all came in, right? When we finished the show, I went back to the hotel room. I repeated the prompt. The feeling is that the event was a success. So he patted me on the back, right? So I'm just saying, you're starting to interact with these things, right? Oh, by the way, the first answer wasn't this. This was the second answer I picked. And this one was the third answer I picked. By the way, the first two answers didn't say it was a failure, right? It just said something else, right? So again, you need to take note, right? When people give you beautiful answers, ask how many times do you try? Yeah. Same model. I was in a hotel room in Germany on top of a hill in Bonn, because the next day I was going to have a conference with neuroscientists and AI scientists coming together to discuss. It was organized by the magazine journal called Nature, one of the top magazines. I was in a hotel room, top of the hill, no supermarket, but there was an apple. I put it there, and then I just kept quiet, no prompt. Right? iPhone take picture and gave it to the Luminous. It says, apple on the wooden table. So very good, right? In the past, it wouldn't say wooden table. Now it does, yeah? Then I made it difficult. I got a glass. Interesting, the German glasses in hotel rooms tend to be pretty small. So I just put it there, confused it a little, kept quiet, and it said, an apple and a glass of water. Now, it's actually very good. It differentiated the two, but mistaken that the glass was filled with water, perhaps because there was a line on the glass. So understandable. Humans can make that mistake too. Take note, right? Humans can make that mistake too. Then I was very nasty. I did it here. I want you all to internalize in your head, what do you think it said? Okay? Then I'll show you the answer. Just guess, right? So this is what it said. Apple juice in a glass, yeah? Okay. Now, to be fair to this model, right? Yeah? Humans can make that mistake too. If someone has not seen this kind of picture before, can make that mistake. But what's even more profound is that when I spoke to the CEO of Aleph Alpha, he said that this model was trained on a lot of humor. Is it trying to humor us, right? Making a joke or something? We don't know. The other point to make about these models is sometimes you don't know why it is saying this thing, right? So things for us to learn. I give it this typical visual illusion picture to Luminous. I've been playing with it quite a lot. And I asked it, of the two horizontal lines, not the circle, because I have to guide it. I don't want it to steer to the circles, right? I say, of the two horizontal lines, it would seem that, guess what it said? First time. The top line is longer than it should be. So you would say this thing is really, really smart. But maybe it is because, well, actually, they are about the same length, it's just an optical illusion. Maybe it's because it has seen a lot of these pictures with a caption below saying that actually the two lines are the same. So it depends on what data you've fed it with that it has seen before. and it remembers it in the billions of connections. Right? And when you prompt it the right way, the right connections fires up and give you the right answer. But not always right. Not always accurate. But it will be given to you in a way that an English speaker will feel comfortable reading. That's what it does well. Okay, these models are big. I drew you 1,000 connections, but GPT-3, which is the precursor to GPT 3.5 and the precursor to GPT-4, right, is 175 billion connections. I only drew 1,000, but this thing is 175 billion, right? Luminous is 200 billion. It can take pictures. The newer GPT can also take pictures, right? Palm, half a trillion. Glam, 1.2 trillion. You know, these are like coming 2 trillion. There is rumor, right, that GPT-4 is about that size too, right? Although it is not officially published, right, as to what it is. The latest model is GPT-4, right? And the newer ChatGPT is based on GPT-4, much smarter. The point I'm trying to make here is that these things are big. Okay? So how do they fit? You buy one server with 8 GPUs, maybe it takes 100 billion connections. If you want 200 billion connections model, you have to cut it into 2, right? And then put it on 2 servers connected with high-performance network. That's the reason why you have all the high-performance computers out there that Ivan has been talking about. You need these, right? If the model is even bigger, or you want to have multiple copies of these models so you can train it differently and then adjust to decide which one you pick, right? This is why high-performance computers are needed, even for training and running of these AI models. Now I switch from large language models to autonomous cars, models to drive autonomous cars. Another disruption. How far back we go? Well, this is me driving in a Toyota Prius in 2014. Right? Right next to me in Silicon Valley came this car from Google. Right? Yeah. This is 2014. Way back, they already started. And then in 2015, 1 year later, again in front of me, on the right actually is the former SGI campus where I was at. And then Google bought over that campus. And you can see that that car, that Google car. So you can see 2014, 2015, autonomous cars training, they are collecting data, has already started. We are coming up to almost 10 years now, right? 2023, one more year, 2024. 10 years of data collection. You need lots and lots of, even more data, right, than training text. Because you have pictures, you have LiDAR, you have radar, you have sonar, right? A lot more data to train. So there was one autonomous car company that has collected 10 million miles of data. 10 million. You know what they say? Not enough. How much do you need? They say 10 billion. How are you going to drive 10 billion miles? No, they don't. They collect 10 million miles of data, after which they use computer games to use the 10 million miles to produce 10 billion miles of computer images to train the car with. So there are simulated data, but you have to be very careful what you simulate it with. So these autonomous car companies do a lot of training with simulated data. So they collect a lot, then after that, you use that a lot to simulate even more data. This tells me big data is going to be really big. Yeah, that's the reason for the slide on Ivan, the first slide, first item. So this is how the car is full. This is not a commercial car. This is a data collection car, full of gear at the back, right? You have LiDAR, you have radar, long, short range, right? And you have sonar, all the different instruments they collect data with, and then later they decide how to trim it down so that it is cheaper on a commercial car. 10 petabytes of data can be collected, right, in a day. How do you upload that data? Well, they get the car to drive itself to the data center parking lot, and then the supervisor came out, pulled the 2 disk drives, and walk up to the data center. That's what they do today, to do the upload. Right? So there's so much data to collect, to train the car with. This also points to the edge, right? So all these large language models, right, you will notice, are put in a data center or in the cloud. But these are models like autonomous cars and on the space station that needs to be on the edge, where you can't afford so much power. You can't afford so much space, right? These are the edge devices that soon will become intelligent also. Here, we put a server on the space station. The dashed line is where the capsule is docked, and the hard line is where the server is being installed on the space station, this way. This is astronaut Mark van der Hey, 2017. It was up for a year and a half. It came back down, and the next system has gone up also. So it was 2 standard servers that we put into this package, right, with a small GPU, right, that will do a bit of AI work, especially in this newer version. Where the hand is held is where you want to plug in, right? We spent months making sure nothing went wrong, but made one mistake. Forgot that cables were too short. We needed a second astronaut to help out with it. Something to note, right? Sometimes you concentrate on the complicated stuff. The simple stuff is the one that gets you. Yeah, learn something. And then you'll notice the HPE logo there. Yeah, just to prove that it is real. Yeah, right. Okay. Yeah. Okay. You can ping, for those who are familiar with Linux, you can ping this computer, right? It takes 700 milliseconds to go all the way up to the station, the geosynchronous orbit, back to the ISS, and then back down again. Very good latency. Yeah. For those who know, you can forgive me for shielding away the IP address. Yeah, right. Okay. Now, if you went from ISS to the Moon and Mars, that 700 milliseconds will be 1 million milliseconds. It will time out. Yeah, it would take too long if this was on Mars. That's the reason why we have to understand all the limitations when it comes to the edge devices. You got the time of flight, how long it takes. Do you have the bandwidth, right? Do you have the power at the other end? All these are considerations that are important for AI also at the edge. We won the NASA Exceptional Technology Achievement Medal. So the edge is something for us to take note, right? If you want the edge to be intelligence and do machine learning also, today they don't do machine learning that much. They only make decisions after they have learned from data center, and the data center model given to the drone, and then the drone flies. And the drone flies based and make decision for you. It is not learning. It is just making decisions, right? What happens if in the future you want the drones to also learn while they are flying? This will be the next phase. Yeah. How do you get them to learn while they are flying? How do you get hospitals to learn from each other without sharing data? Hospitals can't share data, patient privacy, but they want to learn from each other. The models want to learn from, but they can't share data. What do you do? How do you get different banks to learn from each other about fighting fraud without sharing data? Especially at the edge, right? You don't want to share data, but you want to learn from each other. So this is what you do. Google came out with a beautiful answer called federated learning, and this is what you do. Each drone, each hospital, right, or each bank will have their own model. It has to be the same model. And then they do machine learning on their own, no sharing of data. Only learn from their own data. A drone will learn from its own data only, no sharing. Right? And then once in a while, a central coordinator comes in and collect not the data, but the learnings. Those are the connection weights. Just collect the connection information. not the data. So the patient private data is still kept private, but you only give away your connection data, the values of a connection. And then the central coordinator averages it back and send it back out to everybody and update your neural network with the new weights, with the new connection weights. So far, no sharing of data yet. They're just sharing of the neural network weights. Same thing. Then they continue learning locally on their own data, and then the central coordinator collects the weights and connection data and send it back out to everybody to update everybody. So this is one way you can learn from each other without sharing any of your private data. But there was still one problem. When 2018 came along, our customers are asking, who is the central coordinator? If I'm a hospital, I want to join this group to learn from each other, but I don't want any other hospital to be the central coordinator. I want it to be democratic. So this is what we did. We went a step further from federated learning to swarm learning. And this is what we do. Everybody learns locally. A hospital will learn locally on their X-ray data, MRI data, brain scan data, no sharing. And then once in a while, one of the hospitals is assigned to be the central coordinator to do the averaging and then send it back up. Then they continue learning locally, no sharing of data. Then in the next cycle, another hospital is assigned to be the central coordinator in a democratic way. And then it's returned to everybody. So how do you then do this coordination without central coordinator? We use a private permission blockchain. So this is one application of blockchain, not for crypto, but for healthcare, for example. So all the hospitals will come to this network, signed on to the private permission blockchain, agree to the smart contract in the permission blockchain, and then they join the network. And the smart contract will say, we go through a round-robin way of assigning who is the next central coordinator. And if the next central coordinator assigned does not respond in so much time, the next one is assigned. It's a smart contract. And it's now been published at Nature Journal. Do look it up. We use the hospital example, but it could be applicable to drones, banks, and robots, for example. If someone needs a 1-minute blockchain explanation, I was challenged on stage one day by a person in the audience to say, can you explain blockchain in 1 minute? I did it in 1 minute, 45 seconds. I looked this video up. Okay, so I closed my session by talking about what's next, right? This is now guessing, not real, just guess, right? So today, text goes in. For ChatGPT, for example, the newer ChatGPT, text goes in, and then it predicts, it generates an answer for you. As I mentioned earlier, the answer need not be accurate. It will be mostly accurate, but sometimes it can be inaccurate, especially if you ask for numbers, especially if you ask for calculations, especially if you ask it to do math. Yeah. It does very well in the law degree exam, but if you cannot handle, for example, someone tried with Singapore grade 6 mathematics, it failed. Yeah. So what does OpenAI, the creator of ChatGPT, does? They have recently announced that they have connected it with Wolfram Alpha, which is a math library, Mathematica, a math library, right? That will accept, and also Wolfram language. Or you can, the model can talk directly to Wolfram language. You can say, integrate x cubed plus 5. This is what you can do with Wolfram language, right? And now, when you say something like this to the model will know how to call Wolfram Alpha and Wolfram language to do the calculation back to you to give you the answer. They just announced it a few days ago. This, I think, is going to be a huge difference, right, to the latest ChatGPT when it comes to using it for science. Something to note, right? I would like you all to internalize the power of this. these plugins, right, allow you to then have a conversation with a math library to give you an answer. So basically, they use these large language model as a way to accept your verbal input, your natural input, and then give you a natural answer. But in between, they can get accurate calculations. Profound. When I looked at this, it was very profound. In the future, can you do HPC simulation? Computational fluid dynamics. How about airflow over an aircraft or Formula One car? Can you do finite element analysis, the strength of a structure, of a bridge? Can it do all these calculations in the future, right? Well, I give you one scenario, right? I grew up watching Star Trek, right? They like to ask the computer to answer. So imagine you have speech to text, right? And you say, computer, take the aerial photo of city of Tokyo, register it with the LiDAR file of Tokyo, run CFD simulation over the city with the wind blowing in from the east at 20 kilometers an hour. I'm speaking to the computer. And then I tell the computer, give me the answer in visualization as well as talk to me, right? And hopefully in the future, the answer would just be this. I'm not saying we have it. I'm saying the pieces are almost there to make all the different modules talk to each other in the right way. To in the future, instead of having to find a CFD package, study the way it is input, collect the data file, structure it so that to get the visualization in post-processing. So the future is bright for science, I believe, with this, provided we manage it well. And another one, right? What's next? Well, we know that all this while, they can take in music on the left to give you the title of the song, but they are not using large language models. For those who know, they're using fast Fourier transform for this. But OpenAI already has jukebox that actually produce music, even though musicians say it doesn't sound right today. But it's early days yet. So once you have all this, the model can now see and hear. Then taste and smell, maybe not yet. But the minute you give it touch and proprioception, you start to think about humanoid robots. And in fact, Figure AI has just announced that they intend to build one. Right? Maybe not with taste and smell, but definitely with touch. Touch is important when you have humanoid robot because they are hard, right? So you want them to know when they actually touch a human and not to do it too hard. So you are comfortable standing next to them. Very, very difficult. When Figure AI published and announced that they're going to build this humanoid robot, it is 1.6 meter tall, 60 kilograms, and a 5-hour battery. Right? It is not ready yet. They have sketches and CAD drawings. But it's interesting. Go look at their website. They say the chances of success is extremely low. Right? So, but they are one of the best people. All the right people, all the key people they needed for robotics were there, and they've hired them. Right? But they are very pragmatic scientists and engineers. Okay, I close this session with, of course, the governance of it. This one in itself is a multi-hour workshop. Okay, all right. I wouldn't go into details here, but essentially, we don't build the models at HPE. We specialize in taking those models, huge ones, and many of them, and run them well on our platform and services efficiently. Right? But we must also keep in mind the governance factor. So we have an AI ethics advisory board that helps our engineers, partners, and also work with our customers. And I also have to internalize the things that are necessary to understand governance. One, on the input side, right? When you're inputting, the societal and policy side of things are something that I have to keep in mind. On the input side, these things are trained with data on the internet. There are two parts of society here. One, the owners of the data. Is it fair to them? When the model learns from all the painters' pictures, it starts to adopt the style of an individual painter. So you can say, give me Mona Lisa in Picasso style, because it already learned from the style of Picasso. So the artists have a right to say, you learned my style, should they be paid for it? So the society has one side. The other side are the people who train these models with the internet data, and they say there is fair use. In the US, there's a term called fair use, right? As long as it does not replace the original in the marketplace, it is fair use. So, but there are now huge arguments, or I wouldn't say argument, huge disagreement, and yet waiting for a policy to come in to decide owners and users, right, of the data for training. The other area is on the output side. Is the output acceptable to society? Right? It depends on, firstly, the data you train it with. Do you just go in and gobble up the internet data, not worrying about what's in there? Or do you curate the data before you feed it? I remind our people we work with that we take a lot of care in structuring and deciding the textbooks for grade school, because it can influence them. Right? So we should also be taking care of the data we're feeding these very young models. Right? So the feeding of the data, right? The other one is on the output side. Some say, never mind, just gobble up everything on the internet. We at the other end will do human feedback control. The term they tend to use is reinforcement learning with human feedback. So they write a lot of control statements, as to what a human should not do and should do, should say and should not say, and then build a bot that checks the answer coming out from there and tweak the weights whenever it gets it unacceptable. So reinforcement learning with human feedback is one way to control it. Even then, you hear these large language model people say, sometimes it gets it wrong, right? But some put in a strict control with a filter to say that if I think you are asking a sensitive question, I'm just going to tell you, sorry, I'm not going to answer you. So, and then finally, the third part of it is the usage part of it. How should it be used? Here, the policy and regulations need to come in. We know the US Copyright Office have already refused granting copyright, so it already set a bar there, right? Perhaps in the future, these models will have ratings, like movies and games, PG-13 only, right? For example, we don't know, right? We're still early days, but perhaps it will go the same way as movies, TV shows, and games, perhaps, right? And then you have different personality of the same model, a PG-13 model, and a more, maybe a 16 model, and so on. People are already taking different copies of these models, personalizing to that person, those who can afford it. They are already training that model with their own data so that that model looks more and more and talks more and more and acts more and more like that person. There are a number of individuals I know already doing this, because they can afford to do it, big machines, training it daily. Training with all the emails he or she has sent, training with all the press releases he or she has put out, and so on. Companies are also doing this to personalize the model to the company. So I suspect it could be that these models could be personalized by ratings in the same way movies and games are. So all these are coming forward. It's important that we the regulators in the audience, the educationists in the audience, and the users, scientific and creative users in the audience, take note of all these as we move on to understand the disruptions coming from data and AI. Thank you very much. Yeah?
Thank you very much, Dr. Goh, for this lecture. It was very inspiring and interesting. Thank you very much.